It is required that the loading of 3 kilowatt be maintained in a heating element at an initial temperature of 20 degrees Celsius. A voltage of 220 volts is necessary for the purpose of the element has settled down to steady state. It is found that the voltage of 240 is necessary to maintain the 3 kilowatt loading. The resistance temperature coefficient of an element at 20 degrees Celsius, find the final temperature of the heating element. So first we have to write in our given. So we have the power, which is 3 kilowatt. Or simply 3 times 10 raised to 3. Or simply 3,000. Okay, also we have the voltage number 1, which is 220 volts, and our voltage number 2, which is 240 volts, right? We have the initial temperature, which is temperature 1, which is 20 degrees Celsius. Also, we are given the temperature coefficient, which is 0.1236. Okay, so we are asked to find the 2 or the final temperature. So with that, we have to generate two resistances using 3 kilowatts, 220 volts, and 240 volts. We all know the formula. P is equals to I squared R. Okay? We have voltages and the power. So we must find something to substitute to I. A V, we have V is equals to IR. Okay, so therefore I is equals to V over R. So let's substitute. We have P is equals to V over R squared multiplied by R. So we will have P is equals to V squared R, V squared over R. Okay? So therefore, I can also say that R is equals to V squared over P. So at voltage number 1, 220, right? 220 and the power of 3 kilowatts. And at voltage number 2, 240 at the power of 3 kilowatt as well. Okay, tama? Okay. So we have R1 is equals to V squared, which is 220 squared all over 3,000. Our R2 is equals to 240 squared all over 3,000. So we will obtain the value of R1, which is 220 squared divide 3,000, which is 16.13 ohms. R2, which is 240 squared all over 3,000, we have 19.2 ohms. Okay? So since we have that, we write in our formula for this one. We could write in our formula R2 is equals to R1, 1 plus the temperature coefficient versus I multiplied by T2 minus T1. We have 19.2 ohms. is equals to 16.13. 1 plus the temperature coefficient 0.006. 3 zeros, right? We have 3 zeros and 6. Multiplied by the temperature, which is temperature number 2, which is missing, minus 20. So let's write it in our calculator. So we will obtain the value of the T2, which is equivalent to 337.214 or approximately 337 degrees Celsius. So that will be our final answers. This is the unsimplified one and this one is the simplified one.